Okay, so this is Professor Slaughter again, and this is our first video that has to do with the second part of time value of money, which we went over in class the other night. And so this is going to be kind of an amateurish video, done very quickly, but I want to get this information up into Blackboard for you so that those of you that missed class the other night will have the benefit of this analysis. So as we talked about, and what I'm going to take a break right here and take this out of autofocus because it's giving us some problems when we use it as a document camera. So what I want to prove is, even though this formula is starting to get a little bit more complicated, we're essentially not doing anything different than what we did last week when we were working with future value, calculating future value and present value, with just a very simple formula. So I think if I can prove that to you, then you'll have a better understanding of this formula here. So let's look at an example with an annuity where we have, and again, the steps that I recommend when you are doing a problem is to read the problem, draw the timeline, figure out on your timeline how you're going to solve your problem. Select your formula, select your two methods that you're going to use to calculate your answers, compare your answers and make sure that they're right, and then explain what your answer means. Alright, so here, let's say that we're working on a 5-year annuity. Okay, so you're going to get 1, 2, 3, 4 payments. You're going to get 5 payments. And as we discussed in class, this is an ordinary annuity, so the payment's going to be coming in at the end of the period. So that's why the first payment is reflected here. Okay, so let's say that this annuity payment is $100 a year with the final payment coming in. So even though we're really only getting interest for 4 periods, 1, 2, 3, 4, okay, this is a 5-year annuity because the last payment comes in at the end of the 5th year. Okay, so let's just roll with what we already know. Okay, go for what you know. So we know that we're not going to get any interest on this $100 because it's coming in at the end of the 5th year. So that's fine. And we also know that we're going to have to calculate, if we do the timeline like this, we're going to have to calculate the future value of each one of these $100 payments. Okay? And we can tell from our picture that this is one period, right? So we just have one period here. So this will be our n equals 1. And here, the money is going to be invested for this period and this period, so that's n equals 2. We know that this $100 is going to gain interest over a 3-period payout, so it's 1, 2, 3, so n will be 3. And here we know that this $100 will gain interest 1, 2, 3, 4, n equals 4. Okay? Now again, I reiterate, this is a 5-year annuity, but you'll notice that your top n is 4. Your highest n is 4 because your 5th payment's coming in at the end of the 5th year. Okay? Alright, so let's forget about this complicated formula up here and let's just go for what you know. And in this case, we know that the future value is equal to the present value times 1 plus I raised to the n. So I'm going to pull this up a little bit. And we know this formula well because we used it over and over last week. Okay, so I'm going to write this formula over here because once I put my calculator on the piece of paper, I'm going to be moving it around and we want to keep it an eye shot. Okay, so this formula is really simple and I don't use time value money keys on this. I just use my regular calculator keys. And I hope you'll be able to, even though this is a amateurish video, I'm hoping that you'll be able to see what I'm doing in the calculator. Okay, so here we know we're not going to gain any interest. Oh, let's assume here that we've got an interest rate of 8% and this is a 5-year annuity, okay? But you know that your highest n will be 4. Okay, so let me get this all positioned in the camera so that you can see the calculations. Okay, I think this will work for us. Okay, so let's look at this first $100, or this last 100. We know we're not going to get any interest on this. This just comes over into the column to be added in later. And we know that this $100 is going to earn 8% interest just for 1 year. So we should be able to do this in our head. But for those of you who need to use a calculator, you would apply the formula right here. Okay, so we know that the present value of each one of these payments, $100, And we know that the interest rate is 0.08, and then so it's the n that we're going to be changing every time we work the problem. Okay, so I'm going to move this up a little bit so we can see everything. Alright, so we've got 1.08 y to the x. Alright, and we're only going to invest this money for one period, so 1 y to the x, and we're going to hit equals, then times 100. And that's going to give us the value of 108. And again, we probably should be able to do this in our head. Okay? I'm trying to move this calculator out of the direct light again. Okay? Then we have this $100 that we're working on, and that's going to be invested for 2 periods. So again, we're going to refer back to our formula here. So it's going to be 1.08 y to the x to y to the x equals times 100. Okay? And that's going to give this line a value of $116.64. And then here, we're going to do the same thing, but we're going to change this into 3. So 1.08 y to the x, 3 y to the x equals times 100, which is going to give us $125.97. And then this final payment that we're going to be working on, this $100 right here, that's coming over for n equals 4. So now we're going to do 1.08 y to the x, 4 y to the x equals times 100, and that gives us 136.04. Now, the next thing that we need to do, and I kind of wrote my formula in the way, but we need to add up all of these. Payments right here. Okay, let me move this in a little bit to make sure it all comes into focus. So when I add all of these monies up right here, okay, we get 100 plus 108 plus 116.64 plus 125.97 plus 136.04, we get a value of $586.65. Okay, and we get this value, let me push this up a little bit so you can see it. So once I add all of these values up here, I get a total value of $586.65. Now, keep in mind, we haven't used this monster of a formula up here yet, right? We're just using what we know, which is the future, how you calculate the future value as you're setting things up on a timeline. And when we add everything up together, we get a final value of $586.65. So let's take that $586.65 and put that up at the top of the paper so that we don't forget that that's what we're shooting for as far as our calculations. Alright, so now let's go back to this formula. Okay, so we have future value of an annuity, and it is equal to the payment times 1 plus I raised to the nth minus 1 divided by I. And both of these i's carry the same interest rate. Okay, so going back and looking at the timeline, we see that each payment is $100. We've got that. We know that our interest rate is 8%, so that's 1.08, and our N is 5 because it's a 5-year annuity. Okay, and then the interest rate here is 0.08. Now, another common mistake that students will make is they'll put 1.08 down here. Okay, this is 1.08. This is just 0.08. All right. So let's start working through this again. And again, I'm not messing with time value of money keys. I mean, this is pretty simple stuff. So let's do 1.08 y to the x, 5 y to the x equals. And that gives us, hopefully you can see it pretty good in the calculator without too much glare, you have a 1.469328. And we're going to subtract 1 from that right here. Okay? So we're going to have 1.469328 minus 1 divided by 0.08. Okay, and then when we subtract 1 right here, we end up with 100 times 0.469328 divided by 0.08. Okay, so then let me take the 1 out of here. Okay, and then we're going to divide it by 0.08. And that's going to give us 100 times 5.866601. And when we multiply that amount times 100, which is what we're doing right here, guess what we get? We get $586.66. And that's what we got when we did it on our timeline. Remember, here's our timeline here. When we calculated everything out, we got a beautiful number, 586.65. And here we got, and you notice there's a little bit of a penny difference. That's just from doing this is a manual process, and this is using a calculator. And so there may be a penny difference or something. I don't care about that a whole lot. But we've got our final calculation down here of 586, and this is using the more complex formula with n equal to 5, and this was the manual number, 586.65. So I hope this helped you out. I'm sorry that it's such an amateurish video, but I wanted to, like I said, I wanted to make sure that I got something up there on Blackboard fairly quickly for you. So take care. Bye.